So Kevin, this house has this separate building right here with a garage downstairs, but upstairs this terrific family room, playroom up there. Now, it's often difficult to heat or cool these buildings because they're detached. You can't run the ductwork and the piping out, and they're sitting over a cold garage.
Right.
We're going to actually install a system today that can handle both heating and cooling. So Kevin, this space is about 700 square feet. Be perfect as a guest room, as a playroom, or even an office.
Yeah.
You can see it has a baseboard heating system right now that goes around the perimeter, and there's actually a gas-fired propane boiler down in the garage below us in the cold.
Right, so what about air conditioning?
Well, that's what they would like, and there is no air conditioning at all right now.
Okay.
So anytime I think about heating and cooling any space, it starts with a thing called the heat load.
Right.
How much heat is going to be lost on the coldest day to outside, and how much heat will be gained during the hottest day of the year.
So we know it's 700 square feet. That goes into the calculation.
Yep.
What else do you take into account?
Well, it's climate, the local climate, how hot or cold does it get?
Yeah.
Also the conditions of the walls, how much insulation is in the wall, insulation in the ceiling, in this case insulation below my feet
Sure.
right here, and also the level of windows.
Okay, and you've done this calculation?
Yep, we came up with calculation, the heat loss in the winter, 18,000 BTUs per hour goes out through the walls, 16,000 comes in during the cooling load.
Okay, so what do we do about that? We've got a system.
We're going to go with this. This is a split type air conditioner. This unit right here will mount right on the outside wall right there.
Yeah.
We're going to connect it to outside using these refrigerant line sets right here. Now this will come down to an outdoor unit right here. This is a condenser.
Sure.
So in cooling mode, it's going to find heat that's in the building, bring it into the unit, have it travel down through the refrigerant, and dump to outside, leaving cooling inside the building.
And we've seen these before. In fact, we've installed some, and
That's
they're
right.
great for air
And
conditioning.
they're used all over the planet.
Right.
But in the heating mode, it actually reverses that process. It finds heat outside and brings it into the condenser right here, travels through the line set back to here, and dumps heat into the room.
So you can find heat even in like New England colds?
Well,
Because it's going to get cold out there.
This is a thing called an inverter, and actually can find heat even down to 5 degrees. We'll have enough heating power to heat this space.
Really? All right, so how do we get started?
Well, Adam is going to mount his bracket. We're installing this indoor air handler on an outside wall. We actually could put it on any interior wall as long as we get those refrigerant line sets to outside. We'll make our connection between the inside unit and the outside unit with a single 2 5/8 inch hole. We'll use a hole saw to drill the hole from the inside and then finish it off from the outside. All right, so there are 4 connections that we have to make. 2 of them are the refrigerant connections right here. We're going to connect to these line sets outside to either take refrigerant to or from the outdoor unit. The other is this condensate line. Anytime we air condition, one of the byproducts is water that's extracted from the air, and we got to get rid of it. So this condensate line will run water to outside. And finally, there's electricity. We got to run it electricity for the unit. Manufacturer makes this sleeve. You'll notice there's a slight pitch, and that will run all these lines inside here to outside.
Okay. And then the rest of this equipment can go outside?
Yeah, you can actually take that line set outside. I'll meet you outside. So what Adam's doing is running a product called Line Hide. Lets him run all those lines inside here and then snap a cover to really clean up the installation. We'll run that right on the outside of the building, bring it right down to about here. Now at this point is where we want to put this condenser right here. Now this unit has to run both in heating and cooling mode. So if we put it down on a concrete pad like we normally do, we'd worry about snow.
Right.
So we actually want to hang it off the side of the building. There's a couple of angle brackets that'll hang off of this horizontal.
Sure.
And I'll attach the bracket with some lag screws. All right, we've run our electrical wire through the sleeve and we've made our connection here. Now I have to get all this through the sleeve. So just throw a little tape around there, pull it tight, tight as you can.
Okay.
Help us out a little bit. Good. All right, so lift that, your side up, go. I got this side. Let's just walk it up.
There. Just rest it on your ladder for a second. All right, I got it.
All right, Adam, coming to you. Okay. Now we got to hook the top.
Yep, I'm on.
There it is. Good. All right, now our work is outside. We'll connect the copper refrigerant lines with 2 wrenches. Then we'll run those lines as well as the drain and the electrical wire inside the conduit. Okay, good. Adam is using a tubing bender to bend the soft copper without kinking it.
Okay, so all of the lines have been installed along the outside of the building right here. Nice, neat job.
Right, it's a good solution. We've got our drain line run right here. Here's the refrigerant lines bent in place, electrical. Electrician came by and ran a new circuit out to here from the panel, separate circuit breaker, and a service disconnect switch right here.
Perfect.
Last thing we gotta do is get this condenser up here and make our final connection.
All right. Slide it out. Okay.
Bolt right here. Snugged it up and that won't go anywhere. Good. Boy, I like that bracket system.
Got one out
Super.
back.
Yep. Good. Super. For refrigerant connections, we use a flaring tool. It deforms the end of the pipe for a high pressure seal. Now, for controlling these units, they've always used a device like this. It's wireless. You can set the temperature, you can set the fan speed, the vane rotation. You really just set it and forget it.
Right.
You could sit it on a coffee table, or in this case, you could mount it to a wall. But we're not going to use it.
No.
They actually have a new option, which is a wireless clock thermostat. It looks more like a conventional American clock thermostat.
Yep.
It'll communicate wirelessly with this receiver.
So where does the receiver go?
Well, it could go right on the side or on the bottom of the unit right here, but in our case, we can actually put it right up here in the attic above. Okay.
Okay, Richard, all wired up and operational. And I've got the thermostat here, which we can hang on any wall. And with this, we can control that unit.
Right, we can use that, but while you were working on this, I went into the main house and I connected a device called a gateway to the local router. Now, any web-based device can control this unit. It could be a computer, a smartphone, or a tablet like this.
Wow.
So now I can just hit cool and submit, and now it'll send a signal. So now you'll hear the fan come on.
Oh, yeah.
All right. Now the vanes will turn a little bit, and in a little while the condenser outside will come on.
Wow, that is great. So we've got a single unit to give us heating and cooling.
That's right.
I mean, really the perfect solution for this space.
That's right.
That thing's pretty cool.